Alright everyone, it's already 11 past 2 in the evening. So we are going to continue with our chapter 8 topic, force and motion. To be specific, subtopic 6.2 iaitu effects of force. So last class we've learned about effect of force. This class we are going to try to cover two subtopics, that is buoyant force and level. Okay, so we are going to try to finish it before 3. Alright, the first one is buoyant force. We already learned about buoyant force before. We know that buoyant force is a force that makes some object floats on a fluid. Okay, so an object will float if the buoyant force acting on it is enough to support its weight. Okay, if we see this ball right here, there are two types of force that are acting on the ball. Can you write down in the chat box what is the force that acting on the ball? The two type of force that is acting on the ball. Write it down in the chat box. Can you hear my voice? Okay, good. So there are two types of force that are acting on the object that floats in water. Okay, good. One of it is weight, and another one is buoyant force. Good. Okay, so can you tell me the direction as well? What is the direction of buoyant force and what is the direction of weight? The direction, is it upwards or downwards? Which force is upward, which force is downward? Buoyant force up, weight down. Okay, good. Okay, if we are about to draw the force that is acting on the ball downwards is weight, while the force that is acting on the ball upwards is buoyant force. Good. So buoyant force always acting upwards, okay, ke atas. Good, thank you. Okay, so if an object is floating, it means that the buoyant force is equal or more than the weight of the object. Okay, it means that the force that is pushing the ball upwards is equal or more than the force that is pulling the ball downwards. That's why the ball stay afloat on the water. Okay, so it must be more or equal. Okay, for example, we have a duck that is floating on water. So the rubber duck, the weight of the rubber duck is 10 Newton. The weight force of the rubber duck that is pulling the rubber duck downwards is 10 Newton. While the buoyant force that is acting upwards, that is pushing the duck upwards, it's 10 Newton as well. So if the force downwards and upwards is the same, then the duck will stay afloat. It will float. Okay, sebab daya yang menekan dan daya yang menolak pun sama besar. So tak ada yang menang, so dia stay afloat. So that is example number 1. Example number 2 is a stone. If you kalau kita baling satu biji batu, what will happen to the stone? It will sink. Okay, dia akan sink at the bottom of the beaker. Let's say kalau kita letak dalam beaker, it will sink at the bottom of the beaker. Why? Kenapa dia sink? Because the force that is acting downwards, the force yang acting downwards lebih besar, is bigger than the force that is pushing upwards. Okay, take a look at the arrow. If the arrow is longer, okay, meaning that the force is bigger. is if the arrow is shorter, then the force is smaller. Okay, if the arrow is the same length, meaning the force is the same, the magnitude of the force. The magnitude of the force is the same. Boleh faham? Okay, so that is why I told you before, you need to draw the picture in your notes. And you have to draw the arrow as well to show the direction of the force. The arrow also shows the magnitude of the force as well. Although dia tak tulis kat situ berapa, but we know that the force is bigger because the arrow is bigger. And here the force is smaller because the arrow is smaller. That's why it is important in this chapter. The arrow is very important to show the direction and magnitude of the force. Okay, so for this case here, the weight of the stone, the force that is acting downwards, that is pulling the stone downwards, is 10 Newton. While the buoyant force, iaitu the force that is pushing the stone upwards, is 5 Newton. So if we can see here, tarikan yang menarik ke bawah 10 Newton, tapi daya tolakan yang menolak ke atas 5 Newton. So the bigger force is weight that is pulling downwards. That's why the stone sink. Sebab tarikan ke bawah lebih kuat. So the weight is bigger. So it will submerge. Boleh faham? Do you understand? Do you have any question? Do you have any question here? No question. Okay, good. So we can proceed. So how to calculate a buoyant force? How to calculate buoyant force? Okay, buoyant force will only present if an object is on a fluid. Okay, is on a fluid or in a fluid. So buoyant force hanya akan ada apabila objek tu berada di atas fluid ataupun di dalam fluid. Okay, so how to calculate buoyant force? Buoyant force is actual weight minus apparent weight. Maksudnya kita ambil the actual weight in the air. Okay, so what is meaning by actual weight? Actual weight is the weight of an object in the air. Maksudnya dekat atas udara, dekat atas fluid, not in the fluid. While apparent weight is the weight of an object immersed in the fluid. Okay, ataupun di atas fluid tersebut. So how can we calculate? Okay, let's say we are using to measure weight, we use spring balance. We use spring balance. We cannot use we cannot use the usual weighing balance, okay, because weighing balance measure mass, while spring balance measure the gravitational pull. Okay, so the actual weight of a stone here, kita pun kira weight of a stone, kita ikat kat tali, kita ukur dia guna spring balance dekat atas darat. Okay, so the weight is 6 Newton. The weight is 6 Newton. But when we immerse the object, when we immerse bukan stone, glass bottle lid. When we immerse the glass bottle lid in a fluid, okay, contoh fluid ni sekarang ni water lah. Okay, the weight is 5 Newton. So what is the buoyant force that is acting yang menolak glass bottle lid ni ke atas? So how can we calculate? We take the actual weight minus the apparent weight. So we have 1 Newton. So only 1 Newton of force that act on the glass bottle lid. Okay. So in this case, will the glass bottle lid float or sink? Siapa tahu? Write down your answer in the chat box. Others? Sink. Okay, good. It is the correct answer. But why will the glass bottle lid sink? Can you write down the answer as well? Why Why would the glass bottle lid sink? Anyone? You can talk if you want, but you can also write down your answer in the chat box. Because the buoyant force is smaller than weight. Good job. Okay? Yes, it is correct because the buoyant force is smaller than the weight. The buoyant force is only 1 Newton, while the weight is 6 Newton. Because of the weight is greater than the buoyant force, then the glass bottle lid will sink. Good. Thank you very much, Elsa. Meaning you understand what I have been saying. Okay, bagus. Next one. Now we are going to talk about density and buoyant effects. Okay, so we have learned about density before. Object that is less dense than a liquid than water will float on water, while an object that is denser than water will sink in a water. Okay, now we are going to relate it with buoyant effect as well. So object that is less than, why does the object less dense than a liquid will float? Because the buoyant force is more than the weight of the object. Okay, so the object will float. So right now, kita hanya belajar tentang why does the less dense object will float on a liquid while a denser object will sink in a liquid. Okay, kalau sebelum ni kita hanya tahu contoh, for example, a question asks you, why does the rubber duck float on a water? We will say because the rubber duck is less dense than water. Now we are going to relate the density with buoyant effect. Why is the rubber duck float on the water? Because it is less dense than water and because the buoyant force is more than the weight of the rubber duck. Okay, so this is the how we write the force. Okay, so F is upthrust force while W is the weight. So you see here that the weight pulling downwards while the buoyant force acting upwards. Okay, this one need to be corrected a little bit because the buoyant force is greater, so the arrow must be longer. Okay, so here force that is acting upwards, iaitu buoyant force, is bigger than the weight. That's why the object will float, and that is because the object is less than the liquid. Okay, for an object that is denser or more denser than the liquid, the buoyant force is less than the weight of the object. Okay, so the weight is pulling downwards is greater than the force that is pushing upwards. That's why the object will submerge or sink to the bottom of the liquid. Okay, it is the same thing, but you just add up another fact about buoyant effect. Density and buoyant effect. Okay, cargo ships are marked with Plimsoll lines for safety purpose. Okay, if you notice, there are these lines on a body of a ship. Okay, for safety purpose. Difference in temperature and concentration of salt and the density of seawater is different in different parts of the world. Because the density of seawater is different, okay, contoh dekat satu laut, okay, dekat this part of the world, dekat Malaysia, let's say this cargo ship that berlayar dekat atas laut di Malaysia. Okay, disebabkan density of sea water in Malaysia is higher, so the cargo ships akan float lebih tinggi. Okay, but if the cargo ships go near anywhere near Europe, let's say, where the density of sea water is lower, then the cargo ship will sink deeper daripada dekat lautan Malaysia. Okay, because of the density of the seawater is different. So this Plimsoll lines is used for safety purpose. If, okay, let's say, if dekat, okay, this is the meaning. Okay, TF is for tropical freshwater. If at the tropical freshwater, the cargo ships sink below than the line TF. It means it is not safety. It is not safe for the cargo ship to go on. Okay, meaning kalau dekat fresh water F, okay, cargo ship tu mesti float at this line ataupun above, cannot go below because it will be dangerous. Macam tu. So if in summer, mesti dekat line sini S. If it's in winter, they can go, dia boleh sink, dia boleh sink dalam lagi. It will still be okay. Macam tu. That is what Plimsoll lines are for. So Plimsoll lines help to determine the safe level for a ship to stay afloat. Maksudnya kalau ship tu float, maksudnya kalau ship tu sampai sini, dia tenggelam sampai sini, air dekat sini kan. Meaning it is dangerous. Okay, sebab dia tenggelam banyak sangat daripada yang sepatutnya. Do you understand what I'm saying? Do you have any questions about buoyant force? No. So everyone understand about buoyant effect, buoyant force, and density? The relationship between density and buoyant effect? How to calculate buoyant force? Why is an object stay afloat while others sink? You have to be able to explain the situation using the words buoyant force, using buoyant force as explanation, as key explanation. Okay, so if we don't have any more question about buoyant effect, we will stop for 1 minute only. Okay, and then we will continue with level. Okay, after we finish with level, then you will do 2 quizzes for today's class, and then we will end our class. Okay, so you have 1 minute rest. Abang nak ni tak? Tidur Abang, anak kita tidur ke? Anak kita tidur ke? Alright, are you guys still here? Okay, good. So we are going to continue with level. So our next subtopic is level. You already learned about level in your standard 6 in your primary school, right? Have you learned about level in primary school before? Yes, good. So what is level in bahasa Melayu? What is level in bahasa Melayu? Yes, twice. Okay, so you already learned about level in primary school. Okay, do you know how many type of level that we have? Berapa banyak jenis tuas yang kita ada? Yang awak belajar waktu primary school? 3. Good. So this is basically the revision of your things that you have learned in primary school. So that's why we can do this quickly. Okay, kita hanya akan revise saja what you have already learned in primary school. So level. Good. Senanglah maksudnya. So level cuma this time you will need to know it in English term. So tuas in English is level. Okay, so tuas or lever is actually a simple machine. Tuas or lever is actually a simple machine. And the meaning of lever is a bar that rotates on a fixed point. So this fixed point is called fulcrum. Okay, dalam bahasa Melayu pun awak belajar fulcrum. Okay, fulcrum is the point where is a fixed point on the lever. Okay, and then in lever we have 3 different parts. Okay, kita ada 3 different parts, 3 different parts. Okay, the first one is fulcrum, next one is load or beban, and another one is effort ataupun daya. Okay, so the load is where the things goes. Okay, benda yang kita nak benda yang kita nak buat something with. Okay, the load. While the effort is daya. Daya yang bahagian di mana daya ditekankan ataupun daya dikenakan. Okay, you just have to know in lever we have 3 parts. Fulcrum, load, and effort. Okay. Ataupun in Malay, fulcrum. I don't know. I don't really remember the fulcrum. Fulcrum, load is beban, while effort is daya. Okay. This should makes you this should make you easier for you to understand. So 3 parts: load, that is usually labeled with L, effort labeled with E, while fulcrum that is labeled with F. So example of lever in daily life would be when you try to open a can lid with a spoon, or when you try to open a bottle cap with a bottle opener. So lever allow us to do work easily. So imagine if you want to open a can lid. Okay, nak buka tin biskut yang rapat tu guna tangan je. Okay, it will be harder for you because your hand cannot go inside the spaces between the can lid and the can. But if you use a spoon as a lever, it will make your job easier because the spoon can slide into the space and it will become a simple machine. It will become a lever where you put the effort here at the end of the spoon, and this will be your load and this will be your fulcrum. Okay, so lever allow us to do work easily. Lever also allow us to use minimal force. Okay, minimal force to do work. Let's say if you want to remove a nail without a hammer. Okay, how are you going to pull a nail? Takkan awak nak tarik je menggunakan tangan. If you are going to just pull a nail with your hands, you will use a lot of energy and a lot of force. Okay, because it is very hard. But if you use lever, okay, if you use hammer, okay, and make a simple machine using hammer, where you have the fulcrum, the effort, and the load, it will be you will just have to use a minimum effort. Okay, untuk awak tarik ke tepi saja, the effort that is needed is very minimal compared to when you want to pull the nail with your hand only. Okay, so the effort will be reduced. So it allow us to use minimal force to do work. Sama juga to lift this big load. Okay, if you use lever, it will be easier to lift this rock. Okay, compare if we don't use this lever ataupun this kayu. Awak nak angkat guna tangan saja, it will be harder. So lever allow us to use minimal force. Okay, selain daripada make work easy, it also minimize the efforts needed. Okay, this is what you have learned. Classification of levers. Levers can be classified into 3 types. The first class lever ataupun tuas kelas pertama, second class lever ataupun tuas kelas kedua, and third class lever ataupun tuas kelas ketiga. Okay, what is the difference between these 3 lever? It is just the position of the effort, fulcrum, and load. Position of the effort, fulcrum, and load. It will determine the type of the lever. Okay, let's just revise. The first class lever. So the first class lever, what is position at the center? So the fulcrum is between load and effort. So the things at the center will be fulcrum. Fulcrum will be at the center. So first class lever meaning fulcrum is at the center between load and effort. So this is the simple visualization. So example of first class lever would be pliers. Okay, kita dapat tengok ni the fulcrum, the fixed position here is at the center between the load and the effort. Effort adalah tempat daya dikenakan. So kita kenakan daya di sini dan load ni akan pecah. Fulcrum di tengah-tengah. Second one is can opener, where you use effort here and the load is at the end and the fulcrum is at the center. The third one is scissor, the fulcrum at the center, the effort at this end, and the load is on the other end. Okay, senang. Fulcrum at the center is the first class lever. Next one, second class lever. Second class lever, what is at the center? Load is between fulcrum and effort. So at the center would be load. When the load is at the center or when the load is between the effort and fulcrum, it is the second class lever. So fulcrum is at the end, load is at the center. So the example would be wheelbarrow. The fulcrum is at the end, the load is at the center while the effort is at another end. Another example would be nutcracker. We can see that the load is at the center. The fulcrum will be this end and the effort will be at another end. Senang je kan? Okay, and you already learned this before. This is just a revision for you guys. Okay. And then the last one, the third class level. Okay, this one kat sini slide ni salah sikit. It is not load, it is effort. Effort is between fulcrum and load. So the third class level at the center would be the effort. Okay, daya dikenakan di tengah-tengah di antara fulcrum dan beban. Itu adalah third class level. The example of third class level would be ice tongs. Okay, kita pegang tongs tu dekat tengah-tengah. That is the effort. Okay, the things that we're going to lift is the load dekat hujung ni ice, while the fulcrum is at this end. Okay, another one is fishing rod. The load is the fish. Okay, the fulcrum is at the end of the rod, while the effort is at the center. That is why this is a third class lever. Okay, so far, do you have any question about lever? Class, do you have any question about lever? No. Okay, so if you don't have any question about lever, this is where our class will end. Okay, let's recap. We've learned about buoyant force, the effect of buoyant force, why an object can float, why can an object sink, and their relationship with density. The next one we learn about level, the meaning of level, and then 3 parts of level and 3 types or 3 classification of level with the examples. Okay, so that is all that we have learned for today. So you will have before the end of this class, I will give you 2 links and 2 game code for 2 quizzes. Okay, one is for Buoyant Force, another one is for level. So you will have to do it, and as usual, please screenshot your marks for both of quizzes and upload it in the class class WhatsApp group. Okay, so I will put the link. I will give you the link in your WhatsApp group, in your class WhatsApp group, and you will continue there. So before you leave this Google Meet, please write down your name in the chat box and you may leave. Thank you very much for your participation, and please answer the quizzes that I will give you. Yes, your class as well. Thank you very much.